Okay.
Okay.
So the homework, I remember I left the homework. I hope you guys could do it, right? Creating a VPC. The labs are open. There's a section there that you can create a VPC, right? And you know that's good practice for you guys. So to be able to do the VPC, right? And create it. I wish we could have more time in class so I can give you time to create it for me, not for the lab. But we don't have that time. We don't have it. So like I say, we only have 6 hours. Subtract the breaks, subtract the lunch. So it's not much time. Right? Okay, but you can watch some of my videos online. I have a lot of videos that you can watch if you have a doubt about something specifically, right? So let's talk about Route 53. Well, Route 53 is, you have to know that Route 53 is the DNS service of AWS, right? That's the DNS. When you hear DNS service in AWS, that's Route 53. Why is it called Route 53? Well, because Route 53, the number 53 is the port that DNS uses, right? Like SSH uses port 22, HTTP uses port 80, HTTPS uses port 443, email uses port 25, you know, MySQL server, MySQL uses port 3306, PostgreSQL uses port 1452, no, 5412, I think it is, 5412. Then DNS uses port 53. So these are protocols that they use a particular port, right? Um, it's called route because it's like a highway. If you take a look at the in the next slide, as the icon of Route 53 is, it looks like a sign from a highway. Okay, so that's usually how it is presented. Okay, now Route 53 is a highly available and scalable domain service, domain name system web service. Okay, it's a web service and it's a global service. Okay, Route 53 works in a different dimension. It's just in the outer space, along with elastic load balancers and CloudFront. They're there working to deliver content, you know, the quickest way possible to customers. Okay. Well, as it is called, it's a route. So what it does is it routes the traffic, you know, it routes the traffic to users, right? And what it does, it translates, right? It resolves IP addresses, or it resolves domain names to IP addresses, because the browser takes the takes the domain like www.example.com, but the computer doesn't understand the domain. So what it does understand is an IP address, and more than that, it understands binary. So the computer doesn't even understand 192.0.2.1. It understands a binary number, right? And as you can see, the IP address is 4 octets. It has 4 octets. In other words, it has 4 bytes, and every byte has 8 bits. And the bits are zeros and ones, zeros and ones, zeros and ones. So that's the way that the computer understands what is being told to her, or to him, whatever you want to say, if you're going to give it a gender, right? Now, it will help computers to connect to each other, right? It accepts either IPv4 or IPv6, right? IPv4, the type of IP address. IPv4 has, like the one that you see in the screen, it has 4 bytes, 192.0.2.1. So it has 32 bits, right? 8 bytes, 8 bytes, 1 byte, 1 byte, 1 byte, 8 bits, 8 bits, 8 bits, a bit, total 32 bits, right? Now IPv6 has 128 bits. It's a bigger address, right? And it's in hexadecimal. It's not decimal. Like you see here, 192.0 is hexadecimal. It's a different number notation that is going to be used, or still is already being used, but it's going to be um, the IP addresses of the future. Okay, because unfortunately we're running out of IPv4s. Okay? It connects users' requests to infrastructure running in AWS and also outside of AWS. It's used to check the health of your resources, just like Elastic Load Balancer has health checks, right? Route 53 also has health checks of the resources. So if something goes wrong, like there's one of the routing policies that Route 53 has that is failover. It means that if something goes wrong with a particular resource, well, Route 53 has health checks and it can fail over, move the traffic to a different location, right? It features traffic flow, enables you to register domain names. So one of the features of Route 53 is that you can create a domain name, you can purchase it from Route 53, and you can register as well. So it is not, but it acts like a registrar, like GoDaddy or HostGator or Namecheap, that you can buy domains from them. You can buy domains from AWS. It's going to be a little pricier than others, registrars. Okay, but the benefits of that is that you can buy it and register it right there, so you don't have to go to a different company and get it registered there, okay? Or use it there. Okay, this is the resolution of DNS. This is what domain name system that does, right? So you request, right? You send the request to www.example.com, right? And then there's a DNS resolver. That's the server that resolves, the domain to an IP address, right? That's the job of the DNS. Then it would check with Route 53 for IP addresses. So you check if that domain is there, because it resolved to an IP. It checks if the IP exists, right? And it returns that IP, or that result returns it to the DNS resolver. And then that's when that happens, then the user gets the request that he's looking for, okay? Of course, this is only DNS working, but with this, you can have CloudFront with an S3 bucket, or CloudFront with an EC2 instance that has a server there. This is just the user with Route 53, because basically you're not requesting an IP address, right? You're requesting something. You want to see apple.com, right? You just type apple.com. You want to see something in apple.com. You don't want to see an IP address from apple.com. You don't want that. This is just a generic way, like general way to explain to you how DNS works, right? With this, there are going to be other services working. But basically, you type apple.com. It goes to a DNS resolver server. Then it looks for the IP address in Route 53. It finds it. Now, from that moment on, everything goes fine, and then you get a response from the server. Okay, that's how it works, right? So these are the supported routing policies that Route 53 has, right? Now, the first one is weighted. Okay, that's the first guy, right? Well, actually, the first one is simple routing. Weighted is the second one. All right. Use in single server environments. Okay. So we use for the single resource, right? We use it for that, and that performs a given function for your DNS service domain, like a web server that serves content for the example.com website. Okay, that's it. It's one, it's only a single server environment, just www.example.com. That's it. It's the simplest routing policy, right? Like you usually do. Just type a domain in a browser and you get a response, right? Now, the weighted round robin routing, or also known as the weighted routing policy, right? It assigns weights to resource record sets to specify the frequency. Okay? So you use to route traffic to multiple resources in proportions that you specify. Right? It enables you to assign weights to resource record sets to specify the frequency with which different responses are served. You might want to use this capability to do A/B testing, which is when you send a small portion of traffic to a server where you made a software change. For instance, suppose you have two record sets that are associated with one domain name, one with weight 3 and one with weight 1. In this case, 75% of the time, Amazon Route 53 will return the record set with weight 3, and 25% of the time, Amazon Route 53 will return the record set with weight 1. So weights can be any number between 1 and 255. Okay? So basically, you are testing, it's very common to use a um, weighted routing when you create a new application, right? Or you're replacing an application with another, something like that. So you have like one application that you just created, and then you want to test the traffic to that application. You can simply say, well, I want 25% of the traffic to come to this application, but still I want 75% to go to the old application. I want to make sure that this one works fine, but I don't want to send all the traffic there because I don't want to have any failures or any downtime or anything. So let's keep the traffic going to both locations or both applications, right? And then when something tells me that everything is okay, then I can move the entire traffic, the 100% traffic, to the new application. So that's how weighting works. Okay. Also, weighted is also used when one server is under maintenance, right? You can say, well, let me use certain percent of the traffic here and there, and that way you can do it as well. This is very common for blue-green deployments, right? I don't know if you have heard about that, guys. Blue-green deployment. The green is the new environment, and the blue environment is the old one. So you want to move to a different environment, then the deployment process has to be done weightedly. You don't want everything to go to the new deployment just like that, quickly. You want to test the new deployment first, and then you move all the traffic. There's also called canary deployment in AWS, that you can send 10% of the traffic to the new deployment, and after 5 minutes, send the other 90% to the new environment. So something like that. It's the same idea behind that, same idea as the weighted routing policy. Okay, that's very, very common to use canary in deployments. Okay? So latent routing, it helps improve your global applications. Well, you use that when you have resources in multiple AWS regions and you want to route traffic to the region that provides the best latency, right? And latency routing works by using or routing your customers to the AWS endpoint, for example, an EC2 instance, elastic IP addresses, or load balancers that provides the fastest experience based on actual performance measurements of the different AWS regions where your applications run. Okay, that's a latency routing. In other words, you want to send the traffic um, to the location that is closest to your user. Okay? Geolocation routing, right? You use this when you want to route traffic based on the location of your users, right? When you use geolocation routing, you can localize your content and present some or all of the websites in the language of the users. You can also use geolocation routing to restrict the distribution of content to only the locations where you have distribution rights. Another possible use is for balancing the load across endpoints in a predictable, easy to manage way so that the user location is consistently routed to the same endpoint. Okay? Location of the users. Now, geoproximity is based on the location of your resources. Right? You use when you want to route traffic based on the location of your resources and optionally shift traffic from resources in one location to resources in another. Right? Failover, very common when you want to failover to a different region, for example, or a different environment. Okay, so failover to a backup site if your primary site becomes unreachable. Okay? So you use this when you want to configure active passive failover. Right? Route 53 can help detect an outage of your website and redirect your users to alternate locations when your application is operating properly. Okay? When you enable this feature, Amazon Route 53 health checking agents will monitor each location or endpoint of your applications to determine its availability. You can take advantage of these features to increase the availability of your customer-facing applications. Multi-value answer routing. You respond to DNS queries with up to 8 healthy records selected at random. Okay. You use this when you want Route 53 to respond to DNS queries, and then you can configure Amazon Route 53 to return multiple values, such as IP addresses for your web servers in response to DNS queries. So you can specify multiple values for almost any record. But multi-value answer routing also enables you to check the health of each resource so that Route 53 returns only values for healthy resources. It is not a substitute for a load balancer, but the ability to return multiple health checkable IP addresses, it's a way to use DNS to improve availability and load balancing. It doesn't work as a load balancer, but it helps load balancing for that. Okay, it's just when you have one record, one application pointing to different records, to different like IP addresses, right? And then this is just to make this more highly available. So it just returns an IP address randomly. So you have like 8 IP addresses pointing to the same website, right? And then when you make a request, right? Then you can get any of the 8 IP addresses, and then you're gonna be fine because you have 8 different IP addresses that are working for you, right? And of course, gonna be checking the health of those IP addresses. They're working properly, right? And they're sole records. So you can create records. Let me see if I can just log into my account and show you that a little bit better. AWS certification. Okay, so you can see here, create signing and then root account. And then I can have oh, sorry. What's going on here? Complete sign up. Okay. Let's see if it works now. Authentication information problems here. Okay. This is giving me an issue here. Let me see one moment. Why am I getting this? Okay. If I can log in now, guys, I will. I will have to try some other time. That happened to me once, and I had to resync my phone because somehow my guy was not working. Okay? So I have to resync my phone. This MFA is not working properly. Okay. So multi-region deployment. See here we have a user here that is in the United States, and we have an elastic load balancer in the United States, close to the United States, and we have an elastic load balancer in Tokyo, right? That's in Japan. Um, so we have Route 53 as well. We have the name is example.com. We have the alias is the value is the domain name that you see there, right? Now, multi-region deployment is an example use case for Amazon Route 53. With Amazon Route 53, the user is automatically directed to the elastic load balancer that is closest to the user. Okay. So what are the benefits of this multi-region deployment of Route 53? Well, low latency based routing to the region, right? And also load balancing routing to the availability zone. So those are the main benefits of this, right? As you can see, it's going to be sent to this particular place, right? This elastic load balancer, right? It's just sorry, it's a multi-region deployment. Okay, that's what happens here, right? Now, failover. Okay, this is something that you can do in your console, right? I cannot do it now. I cannot show it because it's not letting me log in. But at least you can see that there's a section in Route 53 where you can configure this, right? And then what it does, it improves the availability of your application that run on AWS by just configuring backup and failover scenarios for your applications, enabling highly available multi-region architectures on AWS, and creating health checks. Right? Now, the health checks are created to monitor the health of and performance of your web applications, right? Also, the web servers and other resources. Right? Each health check that you create can monitor one of the following: the health of the specific resource, such as a web server, the status of the other health checks, and the status of an Amazon CloudWatch alarm. So you can do several things that can check. Right? So we have request interval, 30 seconds. You will go faster if you want to. The failure threshold, how many failures it can um, it will understand, right? And then you can say stream matching. No, you don't want any stream matching, like something in the header of the request, right? Latency graphs. It will give you latency graphs, how slow your system is just performing. And invert health check status. No, you're not checking that. I wish I could show you these guys. But some reason this is not letting me log in. I don't understand why. See, it's not letting me. I'm using the correct guy. Okay. So DNS failover for a multi-tier web application. Okay. So we have record sets, CNAME, canonical name, right? www, www, just for. So we have an elastic load balancer, right? Routing policy here, failover, and the record type is the primary. Okay, that's the primary. Then you have a Route 53 website, and now Route 53, an Amazon S3 website. That's a static website, right? And then the routing policy is failover, and the record type is secondary. So what happens when something bad happens, like this primary site is down, right? What happened if we'll fail over to the static content in the bucket, okay? And the website will continue showing like nothing is wrong, right? We just fail over to a website that is a static website, okay? So in the meantime, your company can come in and see what's wrong with this region, okay? This is the primary site, right? So something went wrong with these guys, right? And you see how Route 53 works with Elastic Load Balancer, right? So it's right here, right? The user requests something from the server. You're not requesting from Route 53. You have no idea what's happening behind the scenes. You just request from the server, and the server is here, right? Right? And then Route 53, we just see what's the closest environment to the user, right? Closest location to the user. It will route everything to this guy, right? And then Elastic Load Balancer will be here waiting for that request. Then it will be routing, just distributing the traffic, right, to both EC2 instances. Now, information is being requested from the database, right? So in this standby, right? This is just a standby guy, right? So we can just conclude that this deployment here has multi-AZ. Multi-AZ here, it means that you're going to have a standby database that's going to be there standing by just in case this availability zone goes down, right? So in the meantime, all the requests are coming to this RDS, okay, to this instance, right? If everything goes right, right? Everything goes right. Now, in the meantime, as well, all the information is being replicated to the standby synchronously. This is a synchronous replication, okay? It's happening at the same time. All the writes are being written here. Okay? And nothing is being read from this RDS. Nothing. Until it fails over, then all the traffic from the EC2 instances, they move to this guy. It's just if something happens to this RDS, okay? This database, stops working or something, all the traffic, right? All the traffic moves to this guy, right? And this guy becomes the primary database, right? And it's updated because all the data is being replicated here constantly. That's it. Everything goes fine. If everything goes wrong, something goes wrong, then it will move to the secondary website where you can get the information from the S3 buckets, right? In the meantime, right? You can hold a static website where all the assets are in a bucket, right? Right. So kind of not going to be the same because what you store in um, an S3 bucket is not the same as what you store in RDS because RDS, you can store information, data. You don't store data in an S3 bucket, you store objects that may contain data. For example, logs from CloudWatch or logs from CloudTrail, they contain data, they contain the logs, right? But they probably don't have the name and the last name and the address of a customer. Okay, kind of different storage solutions. This one is for objects. This one is for data, right? Data like data from information, right? But you have to move fast and try to recover this uh, region that's offline, right? So basically, that's how failover works. So Amazon Route 53 is a highly available. This is the takeaways of the session, the section. Highly available and scalable cloud DNS web service that translates domain names into numeric IP addresses. That's the main purpose of. It's not that the only one, but that's the main job of DNS. Okay. Route 53 supports several types of routing policies. Can someone mention to me what are the routing policies that we talked about? Can someone tell me one or two or three? Can someone mention to me?
DNS failover.
Failover, good.
Geoproximity, geolocation.
Geoproximity, geolocation. What else?
Green, blue testing.
Sorry?
Blue, green testing.
That's failover. No,
latency.
That's weighted, right?
Latency.
Latency and weighted. That's the A/B testing. That's for weighted. Okay, so weighted, low latency, geolocation, geoproximity, and we're missing two.
Simple routing.
Simple routing, and the other one?
Multi-value.
Multi-value. So those are the 7 routing policies that Route 53 supports. Okay. So multi-region deployment improves your application's performance, right? For a global audience, right? Remember, this guy works in the global level. It's a global service, right? You can use Amazon Route 53 failover to improve the availability of your applications. Let's talk about another guy that is in the global region as well, the global dimension, is Amazon CloudFront. So now we're going to add Amazon CloudFront to the architecture, right? So when you request information from a server, that request is going to go through different hops, right? Different routers in the way. So the more routers in the way, the higher the latency you're gonna experience. So if I come here to my CLI, just one moment, let me bring my CLI here. So I can do this, right? I can say trace route google.com. I'm just sending a request to google.com and I want to see how many hops in the middle. So I'm going to say this, and then I see that there are 64 hops in the middle. Okay, so those are the hops that we're talking about here. Okay, so you may get a different number because you have a different location, right? Probably, and you're gonna get 64 or 65 or 51. I mean, it depends on your location. Okay, so I see there's several ways and several IP addresses or routers here in the middle of the way that are gonna take you some. It's just about milliseconds. That's why it was so fast. So it all depends also on your speed, internet speed as well. Okay, well, I can do the same to apple.com, right? Trace route, and I can say apple.com, and I get 64 as well. Okay, right? 64 hops max. Okay. It is basically the maximum can go 64, but we get 10 here. You see this number 10? Got 14, right? And here I get 7. Okay. So you can get a different number here, but the hops actually are the IP address that it finds in the middle. I can put another one, for example, my website, and I get 5. Okay, I get 5. Well, actually, it's coming more. They're still thinking. Okay, so try that. If you have a Windows computer, then you will have to tracer. I think it's tracer in Windows. Okay, you can try that. You can put a tracer and a website, a domain name, and then it will give you that. See this one, trace routes. A Cloud Guru. That I don't know. That one has a different. A Cloud.guru. Okay. So, well, that's how it works. Okay, that's the amount of amount of guys that you're gonna find in the way. Okay, so this is the way that works. And when you browse a website or stream a video, your request is routed through many different networks to reach an origin server here. The origin server, also known as the origin, right, stores the original definitive version of the objects, web pages, images, and media files. So the number of networks hops and the distance that the request must travel significantly affects your performance, right, and the responsiveness of your website. Right? In addition to that, network latency is different. Network is different in various geographic locations. So for these reasons, a content delivery network might be the solution. So this is where CloudFront comes in. Okay. So CloudFront is the CDN of AWS. It's the content delivery network. It's a global content delivery network. It's a globally distributed system of caching servers. It uses edge locations, and the edge locations are data centers. Okay, data centers. Okay, it uses discrete data centers to cache the location to cache the information closest to the users, right? That's what it does. It caches copies of commonly requested files, static content, right? And it will deliver that copy from a nearby cache edge or point of presence. Okay. So basically what happens is when the user requests the information, right? The user doesn't know where he or she is requesting the information from, right? The user doesn't know, right? Then the information is taken, the request is taken by CloudFront. Now, CloudFront, the first thing that it does is checks the edge location where the information is supposedly cached, right? If the information doesn't exist, what happens? CloudFront goes to the origin. The origin is, it could be an EC2 instance, or it could be an S3 bucket, or it could be any type of server, okay? It gets the information from the server, from the origin, it brings it back, it gives it to the customer, right? And it just caches the information in an edge location closest to the user, right? So the next time when the user requests the same information, again, not only that user, any user that is in the location, nearby location, CloudFront doesn't have to go back to the origin. What CloudFront does is just gets information from the cache location, the edge location, and gives it to the user with a very low latency. So what it does, it improves the performance of your website remarkably, okay? So a few trips will be saved, from going to the database or to the origin. You don't have to go to the origin every time that someone requests information. It's already cached there, okay? Now, that content may become stale, means that there's a point when that content is not popular as it was before, right? So it becomes it starts to become unpopular. So what it does, it just will place that unpopular document, that information in a region or in a location called regional caches, okay? So CloudFront works with two main components, two main data centers. One is the edge location for most frequently accessed content, and regional caches for less frequently accessed content. So it's going to be working with those two guys, okay? There's going to be more content in the regional cache than in the edge location. So you try to update the content in the edge locations as much as possible, right? It accelerates the delivery of dynamic content. It improves applications performing and scaling, right? So even though CloudFront delivers static content, it can also deliver dynamic content that is unique to the requester and is not catchable, okay? So having a CDN deliver dynamic content improves application performance and scaling. So the CNN establishes and maintains secure connections closer to the requester. If the CDN is on the same network as the origin, routing back to the origin to retrieve dynamic content is accelerated. Okay? So in addition to that, the content such as form data, images, and text can be ingested and sent back to the origin. And in that way, it takes advantage of the low latency connections and proxy behavior of the point of presence. So the point of presence is just an edge location, a regional cache is just, it's just a point where things can be done, cache, retrieve from. That's a point of presence. Okay. Now, it says here that it caches a copy. Sorry, it caches a copy of the commonly requested files, static files. When it says static files, it refers to HTML, right? CSS, JavaScript, image files. That's the static content. And that is hosted on the application origin server. It could be an EC2, it could be an S3 bucket, right? And of course, it would deliver a local copy of the content from a cache edge or point of presence that provides the fastest delivery to the requester, to the user. Well, it's fast, global, and secure. Okay, secure because it has strong layers of security. Okay, even though CloudFront is a CDN, is a content delivery network, it has a lot of security. It's super secure, right? It contains Shield, AWS Shield, and AWS Shield is a service that is an expert in detecting uh, DDoS attacks, right? You can take a look at this guy. This guy is a managed distributed denial of service protection service that safeguards applications running or AWS Shield provides always on detection. So CloudFront will work with this guy, right? So for high level protection against attacks targeting your applications running on Amazon EC2, Elastic Defense, Amazon CloudFront, and also Clover Accelerator on Route 53, you can subscribe to AWS Shield Advanced. So it has two flavors: advanced, a standard, and advanced. Standard's free. It comes with your account when you create it. Advanced, you have to pay for it. Now, you can work with this guy, and there's another guy that also works with this to even secure this even more, and that is AWS WAF, right? AWS WAF. And what is the AWS WAF? Web Application Firewall. Okay, so this guy is also a web application firewall that lets you monitor the HTTP and HTTPS requests that are forwarded to an Amazon CloudFront distribution. So CloudFront is going to be, surrounded by good guys. The good guys, they're going to be stopping the bad guys from coming in. So it's going to work with Shield, the advanced Shield. It's going to work with WAF, okay, to make sure that HTTP requests are, really, really, really secure, right? And, there's no DDoS attacks that can affect our application, okay? That's why it says that it's secure, right? It's global network of edge locations and regional edge caches. In other words, it works with a network of data centers, okay, close to the users. Right? It's a self-service service. It can be on its own, right? It doesn't actually depend on anyone. It can be on its own. It works with other services, but it doesn't depend on any service, right? And also, it's pay-as-you-go pricing, right? So it's different from a traditional content delivery solutions because it enables you to quickly obtain the benefits of high-performance content delivery without negotiated contracts, high prices, or minimum prices. Like any other services, CloudFront is a service offering with pay-as-you-go pricing. Now, I have a student in my other class, my evening class, my solutions architect evening class. He's using Route 53, he's using Amazon S3, and he's using CloudFront in his website. I think I show you guys the website already. I think I did. Anyways, I'm gonna show it to you. So this website, it's built with S3, CloudFront, Route 53, and Certificate Manager. Okay, so using everything from AWS. As you can see, it's super fast. Well, actually, it doesn't move to a different page. It's just slide down a little faster than going to a different page. You see? But this is the guy. So he only pays 50 cents a month. Can you believe that? He only pays 50 cents a month for hosting a static website. This is a static website in an S3 bucket. Okay, so there's no way that we inspect this. We see he's using WordPress, I guess. Images here, CSS, GStatic, Google APIs. Okay. So I think he's using WordPress. He chose a theme. It doesn't so it says out here, but I think he uses theme of WordPress, and then he created this website. Okay, but the thing that has the most credit is that he was able to manage all this and set it up in AWS. Okay, creating a website in WordPress is super easy, right? But get it to work in AWS, like configured everything, get it at Route 53 to work with CloudFront, and CloudFront to work with S3, right? And then integrate the certificate here, so you can have a secure website, that takes credit, right? So this is the infrastructure of CloudFront. You have edge locations, multiple edge locations, and regional edge caches. And it gives you an explanation here what everything is, right? So an edge location is a network data centers, right? That CloudFront uses to serve popular content quickly to customers. Regional edge cache, CloudFront location that caches content that is not popular enough to stay at an edge location. It is located between the origin server and the global edge location. Okay. So I already explained this. Edge location is for popular content. Regional edge caches is for content that is not popular anymore, right? And it puts it there just in case it needs it, right? So a regional cache has a larger cache than an individual edge location. So objects remain in the regional cache longer. Okay? So more of your content remains closer to the viewers, which reduces the need for CloudFront to go back to the origin and improves overall performance for viewers. So that's the point. The point is get the content to the users as quick as possible so they can be happy and continue paying. That's the point. But it's really, really, really impressive the work that AWS has done, that in so many years, in 14 years that they've been in business, that they can, they can return their customers by offering them value and offering them great services. That's something remarkable that AWS has done. Right? So benefits is fast and global, security at the edge, right? So Amazon CloudFront provides both network level and application level protection. So your traffic and applications benefit through various built-in protections such as AWS Shield standard, right? That doesn't cost you anything. It's free, right? You can also configure features like ACM, Amazon or AWS Certificate Manager, right? You can create custom secure socket layer SSL certificates at no extra cost, right? You can have your own certificates at no extra cost. If you take a look at Brian's, this is a certificate from ACM, right? And ACM is Certificate Manager, right? You can have this Certificate Manager, right, and get a certificate. You can quickly request a certificate, deploy it on an ACM integrated AWS resource, such as Elastic Load Balancer. You can put that there. Remember that when you create an Elastic Load Balancer, we can put, well, we're given a URL. Take a look at Elastic Load Balancer here, right? We're giving a URL, okay? So this is gonna be unsecure when you create the load balancer, and then they give you a DNS. This is a DNS name for Elastic Load Balancer. When you put it in the browser, it's gonna be unsecure, It's gonna have any certificate. So you have to purchase a certificate and load it into the last load balancer, put it there, add it there, and then it will be secure. But you don't want to give this to your customers, right? I mean, to anyone. You know, oh, my website is the name of the Elastic Load Balancer Saturday class that US East dash one dot ELB dot Amazon AWS.com. You're not gonna give any that to anyone. So what you have to do is go to the ACM certificate, certificate manager, and buy a domain there as well. Route 53. You can buy a domain and then buy a certificate. Both make it secure and make it readable for people. So my website is dunieskiotano.com. Here you go, right? So behind the scene, that domain is going to be pointed to the last load balancer. So, you know, no one's going to know anything what's happening behind the scenes, but there's an Elastic Load Balancer behind it that has this DNS name, right? But your website, your domain that you purchase is pointing to this guy, all right? And you can make it secure.
So if you bought a domain from GoDaddy, they automatically do this for you?
No, you have to configure it. You have to configure it. Look at this. This is my website, right? behind this, my website is, I think is dunieskiotano.github.io. And then it goes back to my website. You see? I had to configure this in Namecheap. Namecheap.com is the website, is the register what I purchased my domain from. Okay? So I have to configure this here because, and I have to log in here. I thought that I had my, I don't know if I have, if I use the correct. Well, I don't remember, forget the password for this guy. All right, so I have to configure this and come here and add some configurations that they tell me. GoDaddy will tell you, AWS has documentation for that to happen, right? So you don't have to memorize anything. There's documentation everywhere. Your registrar is gonna have instructions for you to do it. So when you purchase that from GoDaddy, GoDaddy is gonna give you instructions. And also AWS has instructions of how to do it, okay? But AWS will not do it for you. AWS does it if you buy the certificate from them, if you buy the domain from them, okay? But you buy the domain from GoDaddy. AWS doesn't know that you're buying it from GoDaddy, right? So you have to do some integration, right? I did it once. I forgot the password for this guy.
Professor?
Yes, go ahead.
I have a question. Does AWS offer the ability, so let's say you're looking for a domain, but the domain is purchased, somebody purchased the domain, but it's not used. Do they do the option of asking someone, or reaching out to the person to obtain that domain, or do you still have to do that with yourself?
I don't know about that. Because I never purchased a domain with AWS. But the ones that I know, like Namecheap, you just put a price and they will contact the owner of the domain and see if they agree with that price. Okay. I'm not sure about AWS, to be honest with you.
Okay.
That's something that can be tried, you know? So the question would be, does AWS request maybe a price or price from another person that already possesses a domain name? Let me see. Domain registration with Route 53. FAQ. Once you have the domain, you can, because I did this in my account, once you have the domain and you can point it to Route 53 and all that, you will create a hosted zone. And then in the hosted zone, then you can create the records. Right? And of course, you charge for the hosted zones. Oh, these are the records that you can have with Route 53. Most common ones is this one and this one. I'm not sure about that, Mr. Sean. We will have to, maybe you can read this a little bit better. Or maybe ask AWS. Let me have the answer for that. But I'm not sure. I never bought a domain with AWS. I've never felt the need to know about that.
Okay, thank you.
Especially because the prices that they have are higher than, the prices are higher than other name registrars. And I didn't even look at that. Okay. So CloudFront, security at the edge, highly programmable, right? So Amazon CloudFront features can be customized for specific application requirements. It integrates with Lambda Edge, so that you can run custom code across AWS locations worldwide, which enables you to move complex application logic closer to use to improve responsiveness, right? So the CDN also supports integration with other tools and automations interfaces for DevOps. It offers continuous integration and continuous delivery environment, CI/CD. Okay? So it's highly programmable as well. Deeply integrated with AWS. Well, it's integrated with AWS, both physical locations that are directly connected to the AWS global infrastructure. You can use APIs or the AWS Management Console to programmatically configure all features in that guy. Okay. Well, it has no minimum commitments and charges you only for what you use, right? Compared to self-hosting, CloudFront avoids the expense and complexity of operating a network of cache servers in multiple sites across the internet. So it also eliminates the need of over-provision, right? Over-provisioning your resources. Okay. So it also is serve content during spikes in traffic, stripes in traffic. So it's super good when we talk about CloudFront. Okay, things change when we talk about CloudFront. Okay. Now, what is the pricing of this guy? Well, you're going to be charged for transfer out. That's There are three main drivers for cost in AWS. They are compute, storage, and transfer out. Okay, you're going to be charged for transfer out, right? So you're charged for the volume of data transfer out from Amazon CloudFront edge locations to the internet or to your origin. Okay. Data transfer usage is total separately for specific geographic locations. So every region has a different price. Okay. And the cost is calculated based on pricing tiers for each area. Okay. If you use other AWS services as the origin of your files, you're charged separately for your use of those services, including storage and compute hours. You're charged for HTTP or HTTPS requests. Right? So every single HTTP request that is done to CloudFront, right, for content, you're going to be charged for that. Right? Invalidation requests, no additional charge for the first 1,000 paths that are requested for invalidation each month. And after that, it's 0.005 per path that is requested for invalidation. Dedicated IP custom SSL. You pay $600 per month for each custom SSL certificate that is associated with one or more CloudFront distributions that use the dedicated IP version of the custom SSL certificate support. In other words, that's a private certificate, right? It's a custom one. It's one for you, right? So that's going to cost you some money. Well, you can see there, $600 per month for each certificate. Okay. So, for example, if your custom SSL certificate was associated with at least one distribution for just 24 hours, that is one day, in the month of June, your total charge for using the custom SSL feature in June is 1 day, 30 days, $600 equals $20. So that's going to be, in 1 day, it's going to be $20. Just simple math, you know? Use for 1 day, that's $20. Well, basically you're paying $20 per day, right? Which is money, right? But if you have this dedicated IP and you can afford it, go ahead, go for it. That's even more secure. It's only for you. Right. So what are the key takeaways for these guys? Guys, do you have any questions? No? Yes? Maybe, perhaps, maybe next Saturday.
No.
All right. So a CDN is a globally distributed system of caching servers that accelerates delivery of content. All right. CloudFront is a fast CDN service that securely delivers data, videos, applications, and APIs over a global infrastructure with low latency and high transfer speeds. Amazon CloudFront offers many benefits. Okay. And we saw the benefits here. If we move back, we saw the benefits there, right? And module wrap up. We're done with this module, right? So between last Saturday and today, you learn how to recognize the basics of networking, describe virtual networking in the cloud with Amazon VPC, label a network diagram, design a basic VPC architecture, indicate the steps to build a VPC, identify security groups, create your own VPC and added additional components to it to produce a customized network, identify the fundamentals of Amazon Route 53, and recognize the benefits of Amazon CloudFront. Okay. Right. So I'm going to give you guys this question. right? Which AWS networking service enables a company to create a virtual network within an AWS? Within AWS. What do you think is the answer?
Amazon PC.
Okay, so the keywords here are AWS networking service and virtual network. Okay, and the answer is VPC. Very good. Okay, very good. So I'm gonna post these guys on Slack, right? I'm gonna post these guys on Slack. I hope they're still clickable, right? PC, Slack. Okay, so now I'm gonna put here. Yeah, Cecilia, that's for buying domains. Okay, so there you go. More information, guys. Guys, it's 10:17. I give you 15 minutes, 15 minutes to take the knowledge check from Canvas, and then we take 10 minutes break. How about that?
Sounds good.
Okay, so let's go to Canvas, and in Canvas, let's find let's find module module 5, right? And let's do the knowledge check. Okay, so let's do that as soon as possible, and then we're done at 10:30. We take 10 minutes break, and then we're going to be back at 10:40.